problem, which is the lifetime of the sun. And number 4, page 388, number 4. So what we're going to use heavily is the data that's on page 313. We want to calculate the lifetime of the sun, and we're going to assume that the nuclear reactions in the sun consume the inner 10% of its mass, right around the core, because that's the only place that the temperatures are actually hot enough for the nuclear reactions to take place. So the mass of the sun is equal to 2 times 10 to the 30th. So 10% of that is equal to 2 times 10 to the 29th. So that's the amount of the sun that is going to be able to provide fuel for these nuclear reactions. Now on page 313, we find that each time that 4 protons go into 1 helium, then the yield of energy that comes out of that is 4.3 times 10 to the minus 12. A very small amount of joules. But each second we measure that the sun's output is 4 times 10 to the 26 joules a second. So we ask the question, how many of these reactions have to take place every second in order to produce the sun's output? So 4 times 10 to the 26 over 4.3 times 10 to the minus 12 is going to be around 10 to the 38. So we have about 10 to the 38 of these reactions. Now each one of these reactions is going to consume 4 protons, 4 hydrogen nuclei, and 4 hydrogen nuclei have a mass of 4p have a mass of from the same page 338, 6.7 times 10 to the minus 27. So how many times can we do, how much mass then do we use in each second? So if we have 10 to the 38 reactions a second, and each one uses 6.7 times 10 to the minus 27 kilograms, then the amount of mass that's used per second is 6.7 times 10 to the 11th kilograms is the amount of mass that's used per second. Now, the amount of mass that's available is the mass, 10% of the sun's mass, which is 2 times 10 to the 29th, and this is the amount of mass that's consumed a second times 10 to the 11th. So when we do 2 divided by, we can do that most easily by doing this as 2 times 10 to the 29th on top and make it a 0.67 times 10 to the 12th on the bottom. And 2 divided by 0.67 is about 3. And 10 to the 29th over 10 to the 12th is 10 to the 17th. 3 times 10 to the 17th. So this is the amount number of seconds. Now in the problem it tells us that there's 3.2 seconds in a year. So how many years is this many seconds? 3 times 10 to the 17th, or 3.2 times 10 to the 7th equals 10 to the 10th years, which is equal to 10 billion years as the lifetime of the sun.